Now that we've seen how multi-body parts can be created, let's take a look at some examples of why you might consider designing with multi-bodies. The first technique we'll discuss is bridging. Bridging is a technique where two or more disjoint bodies are connected by another body. This technique is useful when you wish to use two known bodies as the basis for defining a third body. Let's use this wheel as an example. I'll roll back to the point just after the two revolved bosses. Here I've defined the geometry of the hub and the geometry of the wheel. These two elements are the most important in this design. They must meet specific standards. The geometry that will connect them is not guided by standards, but rather it will be a freeform shape. By having the hub and wheel in place, I can now use several methods to design the spokes. In this example, I've defined two shapes using split lines on the existing bodies. Next, I've created a loft connecting the two shapes using a center line. The last step is to add fillets to blend the transition between the bodies. Next, let's take a look at the use of multiple bodies to create local operations. This ratchet model is currently a single solid body. What I'd like to do is hollow out the head of the ratchet to make room for the ratchet mechanism. Using the shell feature would be an ideal way to accomplish what I want. Unfortunately, because of the way the model was created, using the shell feature at this point would present a problem. Take a look at what happens when a shell with a thickness of 0.2 is applied, removing the top face of the head. To make the problem obvious, let's take a look at a cross-section of the part. The entire model has been shelled. This type of problem can be avoided by taking advantage of multiple bodies. First, I'll turn off the section view and delete the shell feature. Next, to split the head portion into a separate body, I'll use the split feature. As we saw in the previous lesson, all I have to do is define the trim tool. Cut the part, select the solid bodies. This results in two bodies, as you can see in the solid bodies folder. Now I can reapply the shell feature using the same top face and 0.2 thickness. This time, however, the shell is only applied to the head portion. This is what we mean by a local operation, an operation limited to a single body, made possible through the use of multiple bodies. Before moving on to some of the other multi-body techniques, let me point out a small problem. Suppose now I want to add fillets to this model. Specifically, I want to break the hard edges between the head and the handle. Using the fillet feature, I'll select the edges around this area. When I click OK, I'm left with an interesting result. We'll examine this problem in the next lesson.